with the trig identities. So let's look at a couple of different kinds of things that we're going to be asked to do. So one is to complete the proof of the identity. So we can see here the identity is actually worked out for you, but we have to choose the correct rule that was applied. So again, remember, think Pythagorean identity here. So in fact, cosecant squared x minus 1 is the same as cotangent x. So that replacement was made. So when I go to choose the rule, I would choose the Pythagorean identity. And then when I'm looking at these two steps, I can see that cotangent was replaced with cosine over sine. So that would be applying that quotient identity. And then finally, when I do the multiplication here, remember we can think of this as sine squared x over 1. So the sines would cancel and I'm just left with cosine squared x. In that case, that's just doing some algebra. So that's what I would choose there. And then that's it. And we hit check and go on. Okay, so that's the expectation there. Let's now talk through one when we have to now do both. So we have to do the algebra, but then we also have to select the rule that we're applying. Okay, so I have my white space over here. This is where I'm going to do some work. And let's start with, again, just like those guidelines that we mentioned in the previous video, we're going to see what we can do. We're going to work on the more complicated side of this equation. So I'm going to start with, I'm just going to write this down so we can write this all out. Okay, so I'm going to go ahead and I'm going to multiply here, right? So I am going to use FOIL, right? So that's, remember, first, outside, inside, last, just like we did in algebra class. So when I multiply cosecant times itself, I get cosecant squared. And remember, we write that as cosecant squared x. So now outside, I'm multiplying cosecant by -1, so that's negative cosecant x. Inside, I'm multiplying cosecant by +1, so that's plus cosecant x. And then last, I'm multiplying 1 by -1, which is -1. Okay, so notice that I have negative cosecant and positive cosecant, so those two make 0. So I'm left with cosecant, whoops, I left out the c, squared x minus 1. And now I want to think about those Pythagorean identities. And I know that cosecant squared minus 1 is equal to cotangent squared x. So now let's think about what we did. So that first step to get here, right, we multiplied. So that would just be considered algebra. But when I made the replacement, right, so that's actually how I got to this place right here. When I made the replacement, that was a Pythagorean identity. So let's talk through entering this in Alex. So that first step, we're going to just do that multiplication, and that multiplication really results in that simplified cosecant squared x minus 1. So that's what I'm going to enter. I'm going to hit that for my exponent. And again, the rule I'm going to select is just algebra, and then you're asked to validate. So I hit that validate button and all went well, so I can move on. Now I know that that is equal to cotangent, because that's a Pythagorean identity. So let's hit that, and that's all we got to do. Okay, so then we would hit check and go on. Of course, these can vary in level of difficulty, so we can take a look at another one if you'd like to. We'll do one more. Okay, so I see a lot of squared functions here, so I'm thinking we're probably going to use those Pythagorean identities. So let me start by just jotting this down. Again, I'm going to work on the more complicated side of the identity. Okay, so I know, because that Pythagorean identity is sine squared x plus cosine squared x equals 1. So 1 minus sine squared x is equal to cosine squared x. So I can make that replacement. So cosine squared x replaces this, and that's a Pythagorean identity. I'm just going to abbreviate. So I can go ahead and get that started. So we'll replace that with cosine squared x, and then that gets multiplied. So I'm going to hit this to do the multiplication by tangent squared x. And I'm going to select, I used a Pythagorean identity. So let's see. Okay, so far so good. So now let's see. Okay, so now I've got the multiplication. Let me go ahead and continue over here. So now we want to keep going, right? We know that we want to end this, our final thing should be sine squared x. So I'm going to go ahead and rewrite tangent in terms of sine and cosine. So this would be cosine squared x, and then instead of tangent, I'll say sine squared x over cosine squared x. Okay, and I can see this kind of emerging, right? Remember, that's the same as cosine squared x over 1. My cosine squared x's are going to cancel, and that's going to leave me with what I wanted, that sine squared x. So what did we do? We made that replacement, which was not a reciprocal, but a quotient identity. And then as a last step, we did some algebra and ended up with our sine squared. So let's see, we'll do that. Next step, we'll rewrite tangent in terms of sine and cosine. Times, then I'll need a fraction, so that's sine squared x over cosine squared x. And that's a quotient. Validate that. Excellent. Now we're going to do some multiplication like we did over here. And when we do that multiplication, we'll just end up with sine squared x, and that is just some algebra. So I'll hit validate, and our proof is complete. So hope that helps, and that will conclude this video.